Okay, guys, we are going to breeze through our Unit 7 and 8 review. I'm going to do some of the harder ones in each section. Your 8.1 and 8.2 homework is really what's going to help you. So if you haven't completed that one, you better do that now. Stop the video now and do that. 2, you're not going to be ready for the test. So we'll start with number 3. So we have some simplifying. What I like to do is I like to go in there, and if you see a minus in front of if you see a subtraction in front of a parentheses, I like to go in there and change all the signs. So then, I know it's kind of hard to see all the problem. So then what I do from there is combine like terms. So I like to, it doesn't really matter who you start with. We could start with just the plain all A's. So that would be 13A minus 11 minus 3A. So that gives you a negative A. And then, so then I also like to cross them off as we combine like terms. And then I go to the A squared. And this order does not matter. I'm not counting off for order. So you got a positive 11A squared and a negative 10A squared. So that's a positive A squared. Cross them off. And then there's no more single A, so then I go on to the 12A squared. So that's 12A squared, and I think that's the only 12A squared B5. And then we have B to the third A to the third B squared. So that would be, that's positive 12, positive 7, 19A3 B2. And then our B to the fourth just goes last. So basic simplifying. So then on the next section, we can do, say, number 5. Number 5, I would write this parentheses twice. Okay, and then you have some distributing to do. The reason I like to work this one is most people try to shortcut it, but it doesn't work always with the shortcut. So negative 8x, positive 64x, oopsie, x squared, negative 8x, positive 10y, negative 80xy, and then a negative 80xy, and then a positive 100 y4, and then we put together our like terms, which will be the middle two terms. So your final answer is 64x2 minus 80, oh, not minus 80, minus 160 xy squared, forgot my little squares, plus 100 y to the fourth. Alright, so the next one we'll jump down and do some, one of the harder naming ones. Before I move on, ones like these, you would also all distribute, so it gets kind of long, but it's not difficult. Make sure that when you multiply, you add exponents. So let's look at, say, number 16. 16 we name by degree, and it's always named by the highest degree. So we look across, highest degree being the 5th, so that's called a quintic. And so it leads up to, it starts with constant, linear, quadratic, cubic, quartic, quintic, and then after that it's like degree of whatever. So for instance, this one's a degree of 8, and it's a monomial, one term. This one is a quintic degree polynomial of 1, 2, 3, 4, 5. So poly of 5 terms. So this one is a trinomial, cubic trinomial. This one is a quadratic binomial. So you get the idea about that. So then number 18, I know that it is a quartic trinomial, but you can actually factor these like the regular old quadratics. The only thing is now you have to check if this x is squared, you have to make sure that it's not a difference of perfect squares. So this one turns into x plus 3 and x minus 3. The other one doesn't change because one it's a plus and you can't go any further with it. Alright, let's jump to number 20. Oh, I was going to do 19. So 19, it is still a quartic trinomial. It is a slide and divide because of the number in front, so we slide it back. And so then we're trying to come up with a combination of numbers that multiply to 80 and add to 16. I believe it is, I gotta go to my calculator. I think it's 80. Let me multiply that one more time. So that's 20 and 4. Okay, and then I have to remember that in slide and divide, I always go back and divide by the number that I got slid back. So when I divide by that 5 that I slid back, I get x squared minus 4 Is that right? Oh, I messed up. Look at that. See that positive 16 I have in the middle? I did not bring that down, so it'll change these signs. So we get x squared plus 4, and this 5 and this 4 don't reduce, so I slide that 5 up with the x squared, and that's as far as you can go on those. Alright, so we're going to do number 22. Number 22 is a grouping problem. So what we'll do first is check GCF. So GCF across the board, nothing all in common. So I move on to doing grouping, and I'm going to take out a 2x squared. I'm going to take out a minus 3. So one parentheses is what I took out, x squared minus 3. The other one is what's left, and in both expressions you should have x minus 3, or excuse me, plus 3 left. And that's as far as you can go. Alright, so let's go to number 28. I like 28 because you see a synthetic division. You can use synthetic because it is a linear term you're dividing by. So really it would be written in that order. So if I'm going to divide this, I solve it, and r would be 2. So this would be the number that goes in the corner. My coefficients in order. So notice that I'm missing my quartic term between these two. So I'm going to put a 0, negative 32. I'm missing my quadratic. Oh, I'm not missing my quartic. I wasn't even paying attention. So here's my quintic, quartic. I'm messing up all over the place. So 8 minus 32 is my cubic. There is no quadratic, and there is no linear either. Okay, so you drop the number, and you drop it, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, and we get a remainder of -9. So the problem with the ones that look like this with a number with the linear term when you're dividing, whenever you get your answer, so our answer, it started, excuse me, it started as a quintic, and I'm going to go down by 1 degree, so it'll be r to the 4th plus 16r to the, r to the 3rd. And my remainder is -9. But the problem is, on these always, like with the number right here, you have to go back and divide it out, because if I did long division, it would work out fine. I don't have to simplify anything. But because we're kind of cheating and like using the synthetic division, that's why we have to go back and divide by 4. But you don't divide your denominator by 4. That just stays like it is. Alright, so let's do a long division problem. That would be number 25 is long division. Let me go get a piece of paper. Alright, so what I'm going to do is I'm going to divide by 6. I'm going to just leave them x squared. It really bothers me when they're different letters. And make sure it's in order, so 48k to the 4th plus 12k to the 3rd minus 114k squared plus 48k plus 4. But what I didn't do, sorry, I can't see that. What I didn't do is I should have filled in a 0 for my missing linear term on what I was dividing by. Okay? So anytime anything's missing, you have to put a 0 in its place. Alright, so we first start with dividing. So that's 8k squared minus 48k to the 4th. So you divide just the first term, and then the rest of these will multiply here. So that's 0, k to the 3rd. K. Okay, I have x's and k's. I'm sorry. Let me fix this. There we go. Alright, so then 8k squared times -6 is -48k squared. I make sure I switch my signs. Cancel. 12k to the 3rd. Negative 114 minus 48 is negative. Oh, it was minus. Now I made it a plus. Got it. Watch your signs. I'm such a good example. Alright, so then what you do is then divide. So then that's going to be plus 2k. Multiply 12k to the 3rd plus 0k squared minus 12k. Go back and switch, aka subtract. So then cancels, negative 66k squared plus, I feel like I'm missing it, that's 60k, drop the 4, drop your last term. Okay, and then we go through and divide again, so 6 and a negative 66 is negative 11, no k's, because remember in division it goes down by 1, so then negative 66k squared, 0k, plus 66, but then I make sure I go through and change my signs, so my remainder is making sure I'm checking my work. Okay, 60k minus, what is that, 62? So that whole thing is my remainder. And I put it over what I divided by. So make sure on long division, fill in missing terms, and you go through the operations of divide, multiply, subtract, divide, multiply, subtract. All right, so let's look at our next one. We have 34. What was I doing on 34? Okay, so with possible, it says state possible rational roots and then find them. Then factor and find all roots. So if you can factor, you want to factor. I can't factor number 34. So my possible ones are factors of 1 over factors of 4. So 1 over 4 would be 1, and then 1, 2, and 4 are factors of 4. So when I divide those, so 1 into that is just 1. That also gives me 1/2 and 1/4. So I'm going to check the one that it possibly would be, which would be probably the 1 or the negative 1. So I take my polynomial and I do synthetic division. And if you don't like the table, you don't have to do the table. I could also just do synthetic division like normal. Okay, and we can see that the negative 1 is not going to work out, so I might as well just stop. Okay, you do not have to do all the possibilities. If it doesn't work, it doesn't work, and you move on. Okay, so then what I do, you can see my work, sorry. So now I do positive 1, hoping this one works and not one of the negative ones. So you can see I'm working through multiplying and adding, and this is good news because this is 0. So what I have left, so that means that one of my zeros is 1. So the one that worked, which was 1, these are all my possibilities. The one that worked to give me a remainder of 0 is the one that will be my rational root. This is a rational number. So to find the rest of it, I'm left with a quadratic, which you always want to be left with a quadratic. So I'm going to do factoring. So on this one, I'm going to slide and divide. And don't forget to go back and divide. So when I do that, I end up with x minus 1 and x plus 1/4. Now, really, this needs to be split up, but what happens is it doesn't matter because you end up solving. So this one would turn into positive 1 also, because it happens twice, so it has a multiplicity of 2. And then this is negative 1/4. So notice that the highest degree is 3, a cubic, and notice that we still have the same number of zeros or roots. Alright, so for number 36, I'm going to do this one on my paper. So this is a rational, a real number. So real ones don't have partners. So I could write it like that, but it's really not nice to start multiplying with that. So what I do is I slide this up, kind of like in a slide and divide. Okay, so that's better. And then this one has a partner, negative 2 minus I. So right here I'm going to have x plus 2 minus I, x plus 2 plus I. So the only part that not only, whenever you plug it in, of course, signs are always opposite, but the imaginary one and irrational one, the ones with square roots, always have partners. So I'm going to first start with these two. Sorry. So I'm going to start with these two first. So it'll be, so x squared plus 2x plus xi. That should go away. Multiply the last one. So then 2 times x plus 4 plus 2i. And then that is negative xi, might as well put it underneath, minus 2i. So you can see those are all going to cancel. And then minus I squared. So cancels, cancels, x squared plus 4x. Okay, that's that one and that one. Then we have a plus 4 and a negative I squared. Negative I squared, well, I squared is negative 1. So if it's already a negative I squared, it's going to turn into a positive 1. So 4 plus 1 is 5. Okay, and then from there, I would multiply that out. So almost done. So be very careful on simple degrees. Simple. Okay, so there's there. Signs. So why don't I just put it underneath? Okay. So then your final is 4x to the third minus 13x plus 13x squared minus 8x minus 15. That would be a plus 8x. So again, please make sure you do 8.1 and 8.2 before you start reviewing. Although, I guess you're at the end of the video, it's already too late. Good luck tomorrow. Happy Thanksgiving.